RGB. What is it? Well, hello. Hello. How are you? RGB, what is it? Well, literally, it's red, green, blue. Basically, that's it. Those three things. It's the colors that are combined to make all the colors that you see on your TVs, monitors, phones, what have you. Anything with a panel uses RGB to display the picture. Those three colors are used to make up all the colors of the rainbow on a display. It's how color displays have worked going all the way back to the very first color TVs. RGB is not CYMK. CYMK, which is cyan, magenta, yellow, and key is black, are used in printed medium like printers, strangely enough. Commonly, when referring to RGB in computer terms, we're talking about all the flashing lights and color changes that occur within the display, within the case. This has become a lot more prevalent since computer manufacturers, case manufacturers, have started putting clear panels on the side so you can see in. Probably specifically for RGB lighting. I would say this all started way back when, in the earlier computer shows, when displays were trying to show off the various components within the systems. The vendors would have either no side or a custom clear glass side, and then put lighting within the case to show off specific components within the case. People have taken hold of that and carried it on further. The initial lighting was just one color and was probably fluorescent tubing, to be fair, and that has now evolved into multicolor strips and lights almost everywhere within the case. Early computer lighting used LEDs of a single color. This then evolved to RGB lighting, where you could choose what color you wanted to use. Analog RGB connections were added to motherboards, so you could control the lighting from the motherboards. These came in either 4 pins or 5 pins, where the 5th pin was used for a white channel if the strip supported it. 4-pin strips were still able to be plugged into 5-pin headers. That wasn't a problem. And I know that for a fact because my last motherboard has a 5-pin header on it, and my 4-pin connections worked fine with it. Then came digital RGB. This uses a 3-pin header on the motherboard, and instead of running 12 volts like the older analog RGB strips, this uses a 5-volt pin. Digital RGB is meant to allow separate addressing for each light on the strip, so you can choose what each individual light on the strip does. It allows for more complicated type of lighting effects. With RGB came additional expense and complexity and cable management. A case fan with RGB needed an RGB as well as a PMW cable to manage its speed. If you wanted more than one RGB fan or component, then your motherboard needed to have more than one header, or you needed additional equipment like an RGB hub. I have one of those in my case. Others need their own controller like the Corsair equipment. Some fans need their own hub like the Lighting Node Pro. Mine controls up to 6 Corsair RGB devices. With motherboards and hubs and controllers, you need the software to control the lighting. The initial software was basic, and to be fair, with analog RGB, there is only so much you can do with it anyway. But each motherboard component manufacturer uses its own software. For example, Corsair RGB hub is controlled by the IQ software, as are the Corsair mice and mouse mats and keyboards. And even some Corsair power supplies, even though they don't have RGB, it wouldn't surprise me if they started coming out, have some link within the IQ software. But never the twain shall meet. Logitech equipment cannot be controlled by the Corsair software or the motherboard software. Razer equipment will not be controlled by Gigabyte software or Asus or EVGA. This means you have to run multiple software on to do the same thing for different devices. My computer needs 3 separate bits of software: IQ, Logitech, and the Gigabyte for the motherboard. So while some things have their lighting effects synced, not all do. So you end up with static colors or cycling colors that never match up. Static colors aren't a problem because you just set everything to red or blue or cyan or magenta, whatever you want to, fuchsia perhaps. So it's when you're cycling colors and moving colors and changing them that you have the problem. Some games will connect up through the software and control the lighting on your keyboard just for specific lighting per key on the keyboard. There is a project that attempts to have one bit of software to rule them all, and that is OpenRGB. But that comes with its own set of problems. It can only use the option set that comes with each manufacturer. For example, Corsair may have an option that's called Rainbow Wave, and Logitech may have something called just Rainbow. And you can set that up for each Corsair thing to sync, and all the colors within all the Corsair equipment will sync at the same time, but the Logitech stuff will sync differently and separately. So you still have while there's only one bit of software controlling it all, it's still all flowing separate. You can't sync the lighting between the different hardware options, which is a pain in the ass. Again, unless you just choose a static color for everything. I'm happy to be proved wrong, of course. I haven't looked too far into this software. I only know that it's there. Also, it can't control the extra functionality within the keyboards and mice. For example, the Logitech mouse that I have, the 502 Hero, this software won't control the DPI settings. So I still need to run the Logitech software if I want to change that. Sure, I can say that back to the mouse, but there's no dynamic. You then don't have any dynamic control over the mouse. If you are running the IQ software, then that grabs control away from the OpenRGB software. So you cannot have both running at the same time and have OpenRGB controlling the Corsair lighting. So I'm a little bit of a fan of RGB. It just makes a change, it lightens up the room, so to speak. So we've come to the end of the basic overview of RGB lighting and how it works. I will be planning on going more in depth in the future. So come back if you want to see more. Okay, thanks very much for watching. See you later. Bye.